process versus thread. If you're preparing for exams, interviews, or just want strong fundamentals in computer science, this topic is very important. Let's start from the beginning. First, what is a process? A process is simply a program that is currently running. When you open Google Chrome, when you run Microsoft Word, or when you execute a C or Java program, the operating system creates a process. A process has its own independent resources. It has its own memory space, its own code segment, its own data and heap, its own stack, and its own CPU registers. The most important thing to understand is that processes are isolated from each other. One process cannot directly access the memory of another process. This isolation makes processes more secure and stable. However, it also makes them heavier and slower to create and manage. Now, let's talk about threads. A thread is the smallest unit of execution inside a process. You can think of a thread as a lightweight process. A single process can have one thread, which is called single-threaded, or multiple threads, which is called multi-threaded. For example, when you open a web browser, one thread may load the web page, another thread may handle user input, and another thread may play video or audio. All of these threads belong to the same process. Threads share the same memory space. They share the same code, the same data, and the same heap. However, each thread has its own stack and its own registers. Because threads share memory, communication between them is very fast. This makes threads more efficient and better for performance compared to processes. Now let's clearly compare process and thread. First, memory. A process has its own separate memory space. A thread shares memory with other threads in the same process. Second, communication. Processes communicate using inter-process communication mechanisms, which are slower and more complex. Threads communicate easily because they share memory. Third, creation and context switching. Creating a process is heavy and time-consuming. Creating a thread is lightweight and much faster. Fourth, security. Processes are more secure because they are isolated. Threads are less secure because a problem in one thread can affect the entire process. Fifth, failure impact. If one process crashes, other processes usually continue running. But if one thread crashes, it can crash the whole process. If you found this explanation helpful, make sure to subscribe to Bitwise and stay connected for more simple and clear computer science concepts.